So for number 3, you tell me there's 3 different ways we could approach this. Number 1 is we could do this all out, like we would if it was a part 2 or a 3, which I am going to. That's going to be the last way I do this. Okay, so pretend this, no multiple choices, solve the following system. It's on a part 2 or 3. We're going to do it all out in a second. But it is multiple choice. Other ways we could do it. Okay, now be careful when we say store. Yes, you can store, but remember, since it is a system, when they give us the answers, this is an X and this is a Y. So if we are going to use this whole store deal, you store in -5 into both and cross your fingers that you get what? -9. That would be a solution. Everyone see that one right there? And then if it is, okay, well, what about 0, 6 then? When I plug in 0 for X, do I get 6 out? When you have a system, your answers are X and Y, just not all X's. So that is one way you could do it. Store in the X value for both. Do you get the corresponding Y value out? Anybody else? This is a stealth way, by the way. Another way instead of storing. Remember, we're looking for the solution of these two. Here's a hint. Use this bad boy. How?
The calculator.
How, Dylan? Yeah, I know, calculator, but how?
Graph it.
Graph it, and where's the solution? Where they intersect each other. So that's the other way I could do it. All good? All right, I want to do it all out because this week you're going to see, well, what if I can't, what if this is a part 2 question? You can't store and you just can't graph it and write down your answers. So how do I do this? By writing it all out. They're both Y equals, right? What are you going to tell me to do? I want to start solving it now. Set them equal to each other, right? Take one, plug it in for Y of the other one. All right, let's do it. 3x, what happened there? 3x plus 6 is equal to Y plus 4 squared minus 10. If it's not already solved for Y, make sure you do that before you set them equal, all right? We got lucky here, but if it's not solved for Y, make them both solve for Y. 3x plus 6. Oh, please, please don't do this to me. What's going to happen here? Not x squared plus 6. No, you know that, and you're better than that. What's going to happen there? FOIL, double distribute, off to the side. X plus 4, x plus 4. Yes, FOIL, double distribute. Boom, boom. Just to save some time, x squared, the middle term should be 8x. Last term should be 16 when you double distribute. I still got that minus 10, everybody. All I'm going to do now, combine the 16 and the 10, right? Combine the 16 and the 10. X squared plus 8x plus 6. All right, come on. We've seen this so many times. What do I do next? We've seen it too many times. I got an x squared up there. I've seen it too many times.
And subtract 3x minus plus.
Get one side equal to 0 because you're going to have to factor in this problem. Yes, get it equal to 0. So go ahead, move the 3x and the 6 over. You move the 3x over, we get 5x. Ooh, what happens to the 6's?
Cancel.
See ya! They're gone. Ooh, can you guys factor this? Darn right you can. How? GCF. Take out an x and be left with? All right, and now keep talking. Both of them. Kids saying both of them? I'm confident in setting this equal to 0. What else do you want to set equal to 0? Yeah, darn right. You got to set the GCF equal to 0. Good. So that's how I get one answer, 0. And my other answer? -5. But when you're doing the system, you got to plug it back in either equation to find the y values. So plug in 0 into either equation up at the top, you'll get a y value out. Plug in -5, you'll get a y value out. All right?
Didn't you say that if we have a show your work problem and we plug it into the calculator that we can write out?
You could.
Okay.
You could. My fear, though, because I've seen this too many times, it'll say solve algebraically. No go on that. Okay, I see the words solve algebraically. We got to do it all out. But if it doesn't,
okay,
go ahead. I use my graphing calculator, went to second trace, intersect, and here's my answers. Honestly, I would prefer you guys do that for this multiple choice question, is graph them in your calculator and see where they intersect. And then we should be getting what here? This one here? All good? Can I move on? Any questions? So 3 different ways to answer that. Store them in, graph them, which I would probably prefer on this one, and then all out if it was a part 2 question. All right, number 5. So we got 7-year lease, $85,000 for the first year, and I'm going to increase that amount by 6% every year. What's the total for the 7 years? Total for the 7 years.
Just paying for it.
Nah, it's not continuously. Not continuously. But nope, I don't see quarterly, annually, monthly. I don't see that here, so I'm not going to use any of those rate. I like it. I like the idea though, because you guys see the percent, so maybe it's a rate problem. But not here, not here. Hey, sometimes maybe I just do it all out by hand. How much for the first year?
85,000.
Okay, let's do it. Ready? It's 7 years, right? 85,000. Can you guys figure out how much I'm going to do for year 2? How much rent is for year 2? It increases by 6%, right? How can I figure out my rent for year 2 then? Help me. I got my calculator in front of me. 85,000 times. Okay, now you guys you're better than this. Is my rent 5,100? No, it went from 85,000 to 5,100. What's that 5,100? How much it increased by, right? So my plus 85,000. My year 2, 90,100. And now times 0.06, add it to 90,000, right? We could keep doing this. Okay, everyone's good on how I could actually finish this multiple choice, because I'm giving you a different method that will probably come up. Now look, what if I change this to a 30-year lease? I know you have 3 hours, but really? We're going to do this 30 times? Maybe not. So let me show you an alternative way that maybe on a part 2 they're going to force you to do. 85,000, 90,100. We're starting to build a sequence of numbers. Anybody know what type of sequence here we're building?
Geometric.
Why geometric?
Because it's multiplying.
We're multiplying by 0.06 every time, right? And adding it to it. So this is a geometric one. This is why I had grab your formula sheet. Grab your formula sheet so we know where it is. Because I'm going to expose you to this throughout this week. I'm adding up, right? The total amount, I'm adding up. Look on your right-hand column for me, please. Everyone see geometric series, not sequence. Sequence is to find a certain term. Series is to find the total. Everyone see that formula? That's the one we're going to use right now to find how much in 7 years. All right, so here you go. Let me jot it down. S sub n A1 minus A1R to the N all over 1 minus R. Now, whoa, please understand, I'm not forcing you to do it this way. I just want to show you this formula because they may ask for it. You have to do it this way in a part 2 question. So I want you to know, oh, geez, I'm actually given that one. Look on my darn formula sheet. Now all I have to do is plug in. N, how many terms are we adding up? 7. A1 is the first term, 85 grand. Minus 85,000. Ooh, here's where you're going to have to just pay attention here. R value, that's the ratio, common, what you're multiplying by. Now be careful here. I know some of you probably want to put this in, right? But am I actually multiplying by 0.06 to get to the next term?
No.
Is 85,000 times 0.06 that 90,100? No, right? What was I multiplying by then? I've given you guys a trick how to figure it out. What is it?
1.06.
How are we getting there, though?
Oh,
Take a term, divide by the previous. Go ahead. 90,100 divided by 85,000. That'll tell you what we're multiplying by. That's your R value. So 1.06, not 0.06, 100% plus that. And what am I raising it to? 7, our N value, all over 1 minus 1.06. And now just put it into a fraction template and roll. Can we get 713,000 out of our calculator? We're looking good there. Again, yes, please just find all 7 terms and add them together. All right, but if I've seen problems already that we haven't done in class, that I've skipped over on the old exams that have said, use a geometric series formula. And I didn't want you guys to freak out. I want you to know it's on your darn formula sheet. All right, geometric series when I add up all the terms in a geometric sequence. 9, let's go. 9.
Actually, can you explain series and sequence?
Sure.
How do you-
Series, when do I want to use each formula?
Yeah, just
Okay, so series, I got it. That's the total. Total of a geometric sequence. Okay, that other formula there, Jared, that's this one, AN equals A1 R to the N minus 1.
Yeah.
That's like, for instance, here you go. 3, 9, 27, 54. All right, dot, dot, dot. What's the 10th term here? So I figure out, I know it's geometric because I'm multiplying by 3.
Yeah.
Right? So now I go A10 equals 3 first term, R value, what you're multiplying by, 3 to the 10 minus 1. And that'll give me the 10th term. So this formula is kind of used to figure out a term in the sequence versus this, the series is add them all up. Good deal?
Yeah.
Okay, you're welcome. Number 9, everybody. I just haven't covered this word yet. That probably you learned last October of your junior year. Inverse. I only want you to think of one thing. Anybody know what I'm going to write down?
the reverse.
What? Yep. Not. What do you mean reverse?
Like if it was 1
Nope.
quarter, then O.
No.
So
I am going to reverse something, but
what would-
Dylan,
X's and the Y.
Boss move back there. Switch X and Y. That's all. Hey, that's all I need you to remember. Inverse. Wherever there's a Y and an X, flip their spots. Keep everything else the same. That's it. Don't touch anything else. So go ahead. Let's rewrite this now. What am I going to plug in first? X equals 4y plus 5. I wish it was that easy and I could just find that as a multiple choice, but it's not. Don't even think about picking one. Oh, it starts with X. They're not the same. What do you think I'm going to have to do to this? Look at the other choices here. I'm going to have to take this equation and look at 3, 4, and 2.
Divide by 4.
No. What's it starting out with? 2, 3, and 4. Y equals, right? So get Y equals here. Help me. What do you want to move over? Now it's on you guys. Let's roll. 4. What do you want to move over to get Y by itself? Yes. Thank you. 5. What do we want to start here? Get Y by itself. Let's go. X minus 5 equals 4y. Solve for y, because look at all my choices. They're all solved. I know it's definitely not 1. Solve for y. Next step to get y by itself. Let's hear it. 13.
Divide by 4.
Yeah. Now, period 3 was a little shaky on what to do from here with that left side. Split it up. Put each of these over 4. So minus 5/4. And then how do I write that left side?
1 divided by 4.
You could do x over 4. You could do that. That's fine. But also what's in front of the x is a 1. So 1/4 x. So what choice are we looking at here now? Oh, 6. What choice are we looking at? 2. Switch x and y. Inverse. Switch x and y. Now, hey, I want to make sure I prep you guys for all scenarios. This here, hey, take a look. This may be written as this. All right, but f of x is the same thing as what? Your y. So if you want to rewrite it before you start, go ahead. So you might see f of x there. Okay, you might see f of x instead, but it's a y. So switch it. 11. Do these 2 more with me here. We're done. Sorry. Can you eliminate an answer for me? Look at the directions. The completely factored. What's your deal, Ryan? I'm getting rid of 1. Why are you getting rid of 1? What's not completely factored in that?
The n squared.
Everyone agree? N squared minus 9. Everyone knows in here you can keep factoring that. So that's not. Now, some of you may go right to storing here. I wouldn't blame you, but just a heads up. You store in a number, number 1's probably going to also come out to be the same number. Okay, but it's not an answer. Everybody see why? All right, so could you go store crazy, store in a number for n, see which 1, 2, 3, or 4 works? Yes, you could. But I actually want to factor this thing right now. That huge, wow, intimidating looking thing. Who's going to help me here? Let's go. 15, you ready, Howie?
Yeah.
I've always told you guys GCF. Look through all those terms. You see a GCF that's common in any of them?
Yeah. And oh no, there's not.
There's not, because the 108 doesn't have an n, right? So usually when we've had 4 terms, 4, and no GCF, we've grouped, right? Howie, how many terms do I have here? 6. Hey, even when you have an even amount, you can group. All right? Yeah, I know we're all used to 4 terms, but even if you have an even amount, 6, 8, 10, hope it doesn't get that crazy, you can group them. So we can group this. How? Just like you would group 4 terms. 1, 2, 3. And let's group. What?
Doesn't have to be like an order of
Nope.
Okay.
Nope. And you'll see why you don't want to change that right now when I go over how to group again. All right, here we go. First up, 11. What can I take out of the first grouping?
N squared.
Okay. What's left, Jake?
N squared minus 9.
Okay. Here's why I didn't want to move them around. I better be left with an n squared minus 9 every time now. And if I moved them around, I'd probably be left with different things here. All right. But I like to think I got where you're going there. All right. Next grouping. What do you want to take out? 6. 4n. Yep. What are you left with? Good. Now remember, you've got to be left with an n squared minus 9. Take out the right GCF next. So you are left with an n squared minus 9. What's that GCF going to be here? 6 again. Plus 12 here. Okay, ready? Ryan, oh. You take out a plus 12. I'm going to be left with what? Negative n squared, right? So take out a what instead? Okay, everyone see that? If I took out a 12, this would be negative n squared. They got to match. So that tells me no way. I got to take out the opposite, negative 12. All right, good job, everyone. Let's keep grouping, though. We're not done. What do they all have in common that I'm going to take out right now? 5? Oh, n squared. Okay, there's one parenthesis. Good. Second parenthesis, remember, is everything left over. Everything left over. 15. Howie, ready? What's left over?
N squared plus 4n minus 12.
Good. Completely factored. Completely. We're not even close to completely yet. Everyone all right? How Howie got what he has in the parenthesis? Just took an n squared minus 9 from each of them. All right, first parenthesis, nice and easy for you. 11, n squared minus 9.
N minus 3 and n plus 3.
Good. All right, next one. 2 numbers that multiply to negative 12 but add to 4, right? 2 numbers that multiply to negative 12 and add to 4. 13.
6 and 2.
Signs.
Positive 6 and negative 2.
Good job. And there we go. Factored completely. Take your time circling the multiple choice too. I'll admit all my mistakes to you guys. I went through this way too fast and got signs mixed. I did all this correct, but when I started circling the answer, I just didn't pay attention because they all look the same. Make sure we're circling number 2, right? One job. All right, last one, 21. What's the equation for this graph? Could be what? Ooh, this is not a store problem. I hate to break it to you. It's not a store problem. We're not going to get away with storing here. Let me start in here. Could you tell me what the answers are? Looking at a graph, what are the answers? If I graph something, where are the answers on the solutions? Where they intersect what? Because I only got one graph here, right? I don't have 2 here. I only got 1. So where are my solutions and my zeros? Just looking at one graph only. Where it crosses the x-axis. All right, so ready? One answer is x equals negative c. Everyone see where I got that one from? Where it crosses. What else do you have for me? X equals?
Negative b.
Negative b. And there's a third answer, which is x equals? Okay, everyone's all right where I'm starting. I'm starting with the solutions. Okay, I need you to dig deep now. Can you work backwards? What do I mean by that? What must have been in the parenthesis before this to get an answer of x equals negative c?
X plus C.
Nick?
X plus C.
X, right? You guys would set that equal to 0. Oh, one answer is x equals negative c. All right, what's in this parenthesis then? X
Plus B.
plus b. And then this one, x minus a, but don't get too happy. It's not choice 1.
Oh, so.
It's not choice 1. We did everything correctly, but it's not choice 1. We need to just remind ourselves one thing from last year, how the graph looks. Anybody remember if the graph, take a look at this one right here, if it bounces off the x-axis versus cutting right through? Anybody remember how that changed your answer? No? Well, yeah, it does, yeah. When it bounces, this answer actually occurs twice when it bounces. So why am I telling you that? If it occurs twice, I'm going to have squared here. So when it bounces, when the graph bounces off the x-axis, that answer occurs 2 times. If it just cuts through, then it occurs once. All right? So just something, quick review there. When it bounces off the x-axis, there's actually 2 answers there. And they're the same one. Hey, they're the same thing. I just have x equals negative c twice. All right, when it bounces. All right, I'm not going to spend any more time with you guys. Let's roll. Let's roll. You guys can get through these. You have a shot at all these. If you're totally stumped, let me know. You guys know where the answer key is. Just let me stop the video and I'll get right back to that.